You're welcome to use the voice recognition assistant.
Well, it's got me back in prison once again. I used my own phone call to contact my daddy. Got 20 long years for some dust in the bag.
Appreciating what I had and being happy.
So what gave you hope that that was something you could...
Hello, Robot.
Yes, I'm here.
Wisconsin Public Radio.
Okay, got it.
Support for WPR comes from MG&E.
Hi, everybody. Welcome to another episode of Toy Trains and Arduinos. Well, this is the season where we do projects that really don't involve our toy trains directly. Here's yet another one I got into with the idea that we would use our voice to control our toy train accessories that we build using Arduinos. Well, that went various ways, and I ended up doing something totally different. I hope you enjoy this video, and I hope, as I did, learn something about voice control and, having fun with Arduinos. In exploring how to control toy train accessories using my voice, I started out just connecting a microphone to an ESP32. Once that was working, we could look at using various ways to interpret the voice and turn that into commands. One of the ways in which I got this working was using the ESP-SR library for speech recognition, and that worked pretty well. I could turn LEDs on and off. And there's a limited set of different wake words you could use. So that would be one way to go, but to use it, I really couldn't use the Arduino IDE. Maybe by the time you're seeing this video, you can, but at that time I couldn't, and so I looked for another approach. So we're going to talk about a radio that was originally built in 1949 and was made by Zenith to be a portable radio that you could also plug in, so you could use it with a battery and without a battery. I've disabled the original electronics and put it in an Arduino and control the dial.
Welcome to use the voice recognition assistant.
Control the dial with a stepping motor. Now I had to pause there for the voice recognition AI inside the radio to tell us it was ready. And so it comes on, it goes to the last station I was playing. In this case, it's streaming audio from my local server. Muting it helps recognize my voice, but if I say, "Hello, robot," Wisconsin Public Radio.
Support for WPR comes from Willie Street Co-op, offering products for playing in the dirt.
And it moved them
seed,
deep, not
starting supplies,
the needle.
soil, and other gardening
It's
products.
under stepping motor
More
control.
information is at williestreet.coop/gardening.
And you can say other things, make it turn up the volume, change station 1, do things like, "Hello, robot. Play jazz music." And so it goes to whatever I said was the jazz station.
We're ripping up Ontario's contract with Starlink. It's done. It's gone.
It's a
People
Canadian
across this country
station.
are changing their shopping
And they're all
habits to
ticked
wake
off
Trump
right now
tariffs,
for
buying
some
Canadian
reason.
at the grocery store, canceling U.S. travel. In that spirit, Ontario Premier...
Hello, robot. Prairie Public Radio. Prairie Public Radio. It helps to know what you're going to say before you say it.
Used to play it, and this is the early days
So
when you come out
that's what we're going to build today.
somewhere else.
You won't have to do any programming. You can just use my
Tell you
code.
what they think the song is about.
So stay tuned for how to do it.
It's about this, it's about me.
Okay, so the parts you're going to need for this project are an ESP32S3. You're going to want to be sure it has at least 2 megabytes of PS RAM and probably 8 megabytes of flash is going to be required. I think 4 will be maybe just a little too little. 8 will be more than enough. And then we have an audio amplifier over here, and that audio amplifier is a Max 98357, and it uses I2S. And what's nice about that's an audio protocol that the ESP32 handles well. And then what we have here is a stepping motor controller for our stepping motor to control the dial. And the stepping motor controller is a TMC 2209. And then these two devices here are both buck converters. This one has a USB output that we will connect to power the ESP32. And this one powers these two peripherals. So these need 5 volts to operate properly. And so these are both taking our 9-volt power supply, 3 amp power supply, converting it to 5 volts, one for ESP32, and then this one converts it for the other two peripherals. And of course, we have some connectors on the board for connecting to the various other things that aren't in the picture. For instance, there's a stepping motor, but there's a DF robot SEN 0539, and that's got a little AI in it for doing voice recognition. So that's how we do our voice recognition. The other things not pictured here are the encoders. So we have a volume encoder and a tuner encoder, and those are read by the ESP32 in order to control the volume and which internet radio station you're listening to. And then the last thing we have is a reed switch. That reed switch is used in order for the stepping motor to find home when it first starts up. So there's a little magnet attached to the needle that closes the reed switch, and that tells the ESP32 where the needle is, and then it can move the needle accurately henceforth. So those are all the components you need for this, besides a few resistors. A couple LEDs, two 220 ohm resistors, a 1K resistor, and one 100K resistor. I already mentioned the buck converters and a 9-volt power supply. So that's all the parts. And so you obtain those. I'm not going to provide links. I just want to make it really clear. I'm getting nothing from doing these projects. So there's no links for revenue on any of my pages. And I'm just not going to provide links since people get confused about that. All right, we're going to move on to the wiring, how this all gets wired together, and then we'll look at some pictures of the build. There are relatively few components, if you think about it, and they're all represented here in this schematic. The only thing not on the schematic is a 5-volt buck converter with the USB output that supplies the power to the ESP32. Other than that, the schematic is complete. And also, of course, the 9 volts power supply isn't there either. Otherwise, you can wire your components up following this schematic. Follow it carefully, obviously. Every connection is important. What we're going to do now, though, So we're going to spend some time just looking at the build itself, the takedown of the radio, 1949 radio, and putting our circuit board in there. This was a fun build.
You're welcome to use the voice recognition assistant.
We took apart the radio, and here we've already put in our stepping motor, and I've got everything on a breadboard wired into the Zenith chassis, as you can see there. And then it'll play. Hello, robot.
Yes, I'm here.
NPR.
Okay, got it.
But marks on the walls. It used to be pink, but the paint has faded now.
So when we took apart the Zenith, we found some electronics in there, tubes, of course, but a lot of the components were a real mess. We had some blown capacitors and other things. So I cleaned all of those out of there. The other thing we did is we took the front off and we added a stepping motor, replaced a bunch of string and pulleys and wheels and that were connected to the variable resistor for tuning stations. And we just mounted a small stepping motor and put the tuner needle right on it. And in order to know where to home it, let's say, to home it at the beginning, what we did was we just added a reed switch and a magnet to it, and that allowed us to get a home position in the code. That gets reassembled, and where the battery would go in the 1949 operation, we just slide our circuit board there and fasten it in place with some Velcro. I also used the metal chassis to install a barrel connector, and that's where our 9-volt power supply plugs in. So one thing you'll have to do is you'll have to program or train the voice commands into the DF robot. And basically, you just follow the instructions on their website. They have a good wiki for it. And training the commands works really well, to my surprise. And you don't need to have the thing assembled. You can just power it up when you get it and program your commands. Training of the wake words, however, doesn't seem to work so well. I tried several different wake words. They all resulted in false positives. In other words, it would wake up for no apparent reason at all when the radio was going. Whereas the built-in wake word, which is hello robot, does not seem to have that problem. The other annoying thing is you program a wake word, it seems to work, and then it seems to stop working. And if you say hello robot, it responds. And then if you use your new wake word, your custom wake word, it works just fine. And then it stops working again. So I don't know what's going on there. Other people have reported that exact symptom. I don't know what that means. It's probably a fault in the device. However, for one wake word, it works really well. It could be you'll find you can program it with a wake word that works better than my experience. All the software is on my GitHub page. It's commented fairly well. You should read through it probably before you do anything. The important thing is, you'll compile and flash an ESP32S3 with this code, but before using the Arduino IDE, of course. But before you do that, under the tools section, you need to make 3 changes. You need to be sure the flash size is set to 8 megabytes. You need to change the partition size so you have at least 3 megabytes of app space. And for the PS RAM to work, it needs to be set to QSPI. Also, at the GitHub page, there's a Python Flask server. This is just some relatively simple Python code that you can run on your computer to stream your MP3 and OGG files to the ESP32. Now, there's no real configuration file for this. You'll have to write Python code to get it to work for you. And so if you're not ready to do that, then that's okay. This is an optional feature. If you use the podcast feature, you also need to set up a cron job. And if you don't know what that is, then don't worry about it. Once you've assembled it, wired it, flashed the ESP32 with the code, and you turn it on, it's going to create an access point called Zenith Setup. And you take your phone or tablet or computer and you connect Wi-Fi to that access point. And then you can take a browser and visit that URL, 192.168.1.4. And there you'll find a page will come up and you'll be able to enter your Wi-Fi credentials so that the next time it powers on, it connects to your Wi-Fi access point. You'll need to say enter them, update, and then restart. And when you restart, it'll come up and should connect to your thing. If for some reason you mess up and you want to get to this page again, you hold the volume knob in and then you power it on, and it'll always come to the Zenith setup, create that access point. So you can get back here. But otherwise, on subsequent boots, it's going to connect to your Wi-Fi access point, and you can come back to the setup page by simply taking your web browser and going to zenith.local. It uses MDNS to do that, so it should work for most devices. Worked on my newer Android devices. Yeah, I'm told it does not work on older Android devices, but works on iPhone and worked on my Ubuntu computer. So that works pretty well. And so you should be able to then configure your internet radio stations you want to listen to, and then presumably you've trained some commands into your DF robot. This is where you associate those command IDs to specific tasks, and it's spelled out on that zenith.local page, so you should have no problem doing that. All right, I'm going to leave you with some concluding remarks as I show you some photos from the build. It was a fun build. But to the point, the thing we learned about voice controlling accessories, particularly for a train layout, the DF robot is no good, because while it says you can train different wake words, for practical purposes you can't. So at most, you could only really have one accessory active if you're going to use voice control. So that makes it unacceptable for me. Maybe that's cool for you. The other thing we explored, ESP SR as another voice technology. That has some potential. You do have available some pre-programmed wake words so that you could set one device to say, hey ESP, and another one to say Alexa or some of the other pre-programmed wake words, but they're not ideal. So, and then also it's really, really hard to program. So that's a no-go for me. Maybe that'll be cool for you. Also, maybe there's an Arduino library for it now anyway. So there's the other thing you can explore. Overall, though, the project was fun, and I got a useful radio out of it. It's been a long, long time since I listened to public radio while I work, and I'm really enjoying that aspect of it. And, being able to tune in the internet radio stations from California and North Dakota and other places around the country, you see differences, and particularly with the Canadian CBC right now, it's all very interesting. Anyway, I hope you found this video somewhat entertaining and maybe useful. And if you build the project, please let me know, because I'd love to hear about your experiences. Until next time, have fun playing with your toy trains and Arduinos. Hello, robot.
Yes, I'm here.
Northern State Radio.
Okay.
Every time I open up the door, I can hear the song that the wind blows. Put a little love into the air. I feel that I can hear the trees in bloom. Lay a seed into the ground and see if it will grow. Now the spring is here.